Hey, what's up, YouTube fans? So what I'm gonna say about on this video, right, is likely going to change the way that you guys think about reptile circulatory systems, right? So a few of the major traits that are like commonly listed as reptile traits are three-chambered heart and cold-blooded, right? But should we really consider these to be reptile traits, right? Um, the reptile circulatory systems are actually more diverse than you would be led to think based on, more outdated classification systems, right? So older, more outdated classification systems, right, would tend to list birds as not part of the reptile group, right? So the system where we use like domain, kingdom, phylum, class, birds and reptiles are actually both considered separate classes, and birds are not considered to be a part of the reptiles, right? And yet, what we now know, right, from genetic analysis, fossil evidence, is that uh, birds, right, are a lineage derived from the larger reptile group, right? So crocodilians, right, which is the group of reptiles including crocodiles, alligators, caimans, gharials, right? They actually share more DNA with birds than they do with other reptile groups like turtles, lizards, snakes, which, by the way, snakes technically are an offshoot of the lizard group. But so even though, like, traditionally in more outdated classification systems, we would not consider birds to be reptiles, and yet we would consider crocodilians to be reptiles along with those other groups. Crocodilians actually share more DNA with birds, right? Um, and birds and crocodilians, right, are together the two living members of a clade called the archosaurs, right? Um, and by the way, part of why I was thinking about this, I'm on vacation right now, and this place I went to, I got to eat alligator tail. So that's part of why I was thinking about this. I was eating alligator tail. My first time eating any reptile aside from a bird, right? Um, and but so in any event, right? Crocodilians and birds, they are both part of the archosaur clade, whereas other reptiles are not, right? So therefore, right, it doesn't really make sense, right, how we do not group birds within the reptile group traditionally, right? And what I'm going to further point out that further all the more makes this the case, right? What is something that we see in all living archosaurs, right? So all birds and crocodilians, but not most other reptiles. Four-chambered heart, right? Four-chambered heart, right? And fossil evidence would indicate that extinct archosaurs, right? Like other dinosaurs aside from birds, right? Like T-Rex, that they had four-chambered hearts, and then also the pterosaurs, they had four-chambered hearts. And interestingly, so there's actually fossil evidence that most of the extinct dinosaurs and also pterosaurs were warm-blooded, right? Because there's been chemical analysis of their fossils, right, which gave insight into their metabolism, and scientists were able to infer, right, that they probably were warm-blooded, right, not cold-blooded. And so some lines of evidence have actually indicated that the earliest archosaurs were warm-blooded, and then the crocodilians only later reverted towards being cold-blooded, right? But with them actually evolving from warm-blooded ancestors, right? And so all of the archosaurs have four-chambered hearts, right, as far as we can tell, right? And most archosaurs, when we especially when we include the fossil ones, most archosaurs are warm-blooded, right? And even if we didn't include the fossil ones, most of them are, because birds far outnumber crocodilians in their species number. But especially when we factor in the fossils, right, most archosaurs, it would seem, are warm-blooded, right? And so, part of what the justification that people would use for still excluding birds from the reptile group, in spite of the fact that it makes reptiles a paraphyletic group, that is a group that includes a common ancestor, species, and some of its descendants, but not all descendants from the last common ancestor shared from them are included within the group. That's what we call a paraphyletic group, whereas a clade is a group that includes a common ancestor species and all of its descendant species. But so one of the justifications people would use for keeping the old classification where we exclude birds from reptiles is that they would say that it makes sense based on certain characteristics that birds deviate, such as their circulatory system. And yet, we really shouldn't even think of these features as being like the features that we traditionally think of as being reptile circulatory system features. We really shouldn't think of them that way. Even if we didn't want to include birds within the group, we still shouldn't, right? Because archosaurs, which is one of the largest lineages of the reptiles, right, especially when we include the fossil record, which I mean is, extinct creatures are just as much real as living ones, right? The archosaurs, right, have four-chambered hearts, and most of them, it would seem, are warm-blooded, right? And so, we really shouldn't even see, three-chambered heart and cold-blooded as being, like defining features of reptiles. There's not really good basis to that based on what we now know, right? And so that considered, all the more, there's not really valid reason to exclude birds from the reptile group. And so this should really, this likely will make you guys, reconsider, the diversity of reptile circulatory systems. Um, and so, and also there's, if you guys want to read more into this, in the comments, I'm going to put some links to some papers where they talk more in depth, right? There's some papers where they talk much more in depth on like the evidence regarding like archosaur circulatory systems. Uh, so and yeah, it's interesting. So I had like first like I had like noticed before that I knew that crocodilians and birds were both archosaurs, and then eventually I noticed like, wait a second, they both have four-chambered hearts. So I wonder if that's like a trait like that is, the case like of the earliest archosaurs, and it would seem the evidence would indicate that it probably was, um, as well as even warm-blooded, which in the case of crocodilians, they're now they are cold-blooded. But in any event, that's all for now. See you guys.